Hello everyone. So today we're going to continue to learn the section 12.5, which is line and plane equations in space. And in the last class, we learned how to find the equation for a given plane, right? So the plane is determined by a point and the normal vector. So let's have a quick review. That is ax minus x naught, b y minus y naught, plus c z minus c naught equals 0. And here capital ABC, this gives us the normal vector, and x naught, y naught, z naught is the given point. So let's see here. Example 6. Find an equation of the plane that passes through the points P, Q, R. Okay, so we can just draw roughly graph P, Q, R. We don't need to know where they are. We just want to draw like this way. And we want to find a plane decided by those 3 points. And for the plane, we need a normal vector. So how to find a normal vector? So we're going to do this way. Given any 2 points, okay, we can make 2 vectors here, right? And we know we get a PQ vector and a PR vector, and the normal vector actually is the vector normal to or perpendicular to both PQ and PR, because this vector perpendicular to the whole plane, so it's perpendicular to anything in the plane, and perpendicular to both PQ and PR. So the best way you can see what's the cross product. Cross product of UV vector. So UV vector is just a normal vector, right? Give us the normal vector. So how to find the normal vector? We just do the cross product of PQ and PR, and then we just use any point PQR. You can pick any one and just write down the plane equation. Now we are going to do this way, okay? So here's the idea of the problem. First step, we find the PQ and PR vector. So PQ vector, Q minus P, so 3 minus 1, 2, negative 4, 6 minus 2, 4. PR vector, point R minus point P. Look at R, 5 minus 1, 4, 2 minus 3, negative 1, 0 minus 2, negative 2. This is PQ, PR. Next, we do the cross product. PQ cross PR. Same thing, the order doesn't matter too much, okay? Because if we find another direction, that's okay. That's also okay, right? We just need a normal vector. So IJK, so which is 2, negative 4, 4. That's the calculation of cross product. And this cross product equals this one. 12I plus 20J plus 14K. And this is just our normal vector. So we can just write down our normal vector as 12, 20, and 40. And the next, you can pick any point as the point x naught, y naught, z naught. Doesn't matter too much. So here I pick the point P. So it's going to be 12, x minus 1, plus 20, y minus 3, plus 14, z minus 2 equals 0. Okay, no matter which point you pick, after we simplify, the general equation will be the same thing. So this is the solution of the plane. Okay. Next, here's the exercise problem, and you can try. Here we have a plane pass through those 3 points. C 0, 3, 0, and here I can give you the normal vector and the plane. You need to double check the answer. You can try this by yourself. Okay, and here is the simplified equation. Okay, and next we have a definition 2. 2 planes are parallel, so it's like we have 2 planes Okay, and if they are parallel, that means if their normal vectors are parallel, are the same thing. Okay, same, are parallel. So two planes are parallel if and only if their normal vectors are parallel. For example, here I give you x plus 2y plus 3z equals 4. This is one plane, right? If we have another plane, for example, 2x plus 4y plus 6z equals 5. So you can see what's the normal vector for the first plane? 1, 2, 3. And n2, the vector, which is 2, 4, 6. Right? So which is actually the double of the n1. So we know they are parallel. n1 is parallel to n2. So that means those two planes are parallel. Okay, so next we are going to do the line of intersections. So if we have two planes like this, we have two planes and they intersect each other. So it's like this way. And we can, if they intersect each other, so there is intersection. So it's like before we do 2D, two lines, if we have R1, R2, they intercept at a point. So right now, we have two planes, intercept is a line. Okay, so next is topic, we are going to do lines of intersection. Okay, so we do this from the example. Let's see how to find the intersection. Example 7. Find a vector parallel to the line of intersection. Of two planes. So the two planes are given by 3x minus 6y minus 2z equals 15 and 2x plus y minus 2z equals 5. Okay, two planes are given. So for the two planes, the first step we need to know from those two planes, you can see the most important information we can get is the normal vector, right? So the first normal vector for the first plane is this one. N2 should be 2, 1, negative 2. That's the normal vector for the second plane. And if we look at the graph, so here that is N1. Here is like N2. Right? N1 and N2. Or we can just draw here. So this is the N1 vector. And here is N2 vector. So you can see because N1 is perpendicular to the plane, we can say plane 1, and this is plane 2. Okay, so N1 perpendicular to the plane, so N1 should perpendicular to the line of intersection, right? And N2 is perpendicular to plane 2, and because L is the intersection of those two planes, so L is also in plane 2. That means N2 is perpendicular to L also. So that means N1 perpendicular to L, N2 is also perpendicular to the line L. Okay, so we shouldn't say L, so direction of the L so should be like the V vector. Okay, so it should be, but perpendicular just means normal to that line. Okay, or we can say to that vector. So how to find a vector that's perpendicular to both N1 and N2? Cross product. Right? That is this is perpendicular to N1 and this vector is also perpendicular to N2. So that vector is just the direction of the line of intersection. So let's do the cross product. I, j, k. 3, -6, -2, 2, 1, -2. And we just calculate this cross product. And the answer is 14i, 15k. Okay, so find a vector parallel to the line of intersection. So that is the vector we're looking for. So the vector we're looking for is parallel, so it doesn't matter the scalar, the length, magnitude, or whatever. So we just need the direction, kind of. So we can just write down the answer like this. Okay. Next example, let's see. We're going to find the point where the line intersects a plane. So it's like we have a plane and we have a line, okay, and intersect the plane, and how to find the P. Okay, how to find that point. And L is given and the plane is given. Now let's take a look at next example. Find the point where the line, and the line is given by parametric equation y equals -2t. So we know the direction of the line. Okay, intersect the plane. The plane is given by this one. Okay, so the given information here, we know a plane, we know a line. So let's take a look. Okay, how to find the point? So, you know, the line is given by x, y, z, right? And the x, y, z, when this line intercepts the plane, so the function should x, y, z should satisfy the line equation. So we just plug the line equation into the plane. Because the point satisfies both equations actually. So we just plug the point, so which is 3, and the point x is this one, and the 2, and what is y? Y is -2t, and the plus 6z, z is 1 plus t. And here we get an equation just with one unknown t. So here we want to solve for t. So that means for what t, the point, the line intersected the plane. Okay, so we just solve for t. And here, let's see, the first, we just simplify. So it's going to be 8 plus 6t minus 4t, right? And the plus 6t equals 0, solve for t. So we combine those t together. It becomes, so 2t, so it becomes 8t. And move the constant to the right side, -4t. Did I make any mistake? -4t plus 6t. Oh, the right side is 6. I'm sorry, it's 6 actually. So plus 6. So should be -8. So 8t equals -8, t equals -1. So when t equals -1, the line intercepted the plane. But what we are looking for, we're not looking for t, we're looking for the point, right? And next, we just plug in the t equals 91 back into the parametric equations for the line. So plug this into the line equation. So the line equation just x and y and z, right? Given by. So that's the point. x equals this one minus 2, which is 2/3, and y equals negative 2t, negative 2 times negative 1, so it should be 2. Z equals what? 1 plus t, 1 plus negative 1, so which is 0. So what is the point? Point is 2/3, 2, and 0. Okay, that's all. So this is how we find the point of intersection when the line intercepts a plane. And you can try this exercise. Okay. The next topic we're going to do is the distance from a point to a plane. So let's see, number 5, distance from a point to a plane. So that means a point is given, a plane is given. Okay, how to find the distance? Like this, right? Okay. So it's very similar to what we did before. Here, if we take a look, I'm going to draw a point in the plane, because for a given plane, x minus x naught, y minus y naught, z minus z naught. So we can find a point. We can find a point, right? Find a point in the plane. Or we can just find if the plane is given by general form. We just find any point that satisfy this plane. That's okay. Any point that satisfy this equation is in this plane. And if we find a point P here, for example, and we can make a vector PS. Is that right? And we are looking for the distance here. Okay. So the distance equals what, actually? The distance equals PS length times, okay, so depends on what is theta. So if we say theta is the angle between, so here let's see what the vectors do we know. We know the normal vector. So this is the normal vector, right? And the other vector we know is PS. So we should set the angle in between PS and the normal vector. So it should be here or here. You can do any method because it's parallelogram, doesn't matter too much. If you just look at the right angle here, so theta is the angle between vector, normal vector, and PS vector, right? And we can see distance equals what? The PS vector length times cosine theta. And the distance equals PS length times cosine theta. Who has cosine? Dot product has cosine. And divide by this one. And this equals what? PS dot n vector, just divide by length of n. That's all, right? So this is the formula for the distance from a point to a plane. Now we can take a look at the example. Find the distance from the point to plane 3x plus 2y plus 6z equals 6. Okay, so the first step, we want to find a point in the plane. So we just want to find any xyz that satisfy this equation. So the easiest way, we can just find, you can make x and y equals 0, solve for z. So for example, 0, 0, 1 satisfy the equation. Is that right? Because when x is 0, y 0, 6 times 1 is 6. So this point is on the plane. Or you can find, just make xz equals 0. So 0, z equals 0, and solve for y is 3. This point is also on the plane. Because they all satisfy the plane equation, so they are just on the plane. We can find a lot of points on the plane, so we just want to find the easiest one. So you can pick any one, any point you like. And if we make a yz equals 0, so it should be 2, 0, 0 on the plane. So for the P point, you can use any one. So here, for example, if I use the P as 0, 1, so if my P is 0, 0, 1, and look at the graph, what do I need here? I need the PS vector. And the point S is given minus point P. So it should be 1, 1, 2. Right? And next, what do we need to do? Dot product. PS dot n vector. So here we need to know what is the n vector, right? Let's write down the n vector first. So n vector is the normal vector to the plane. The plane is given, so we can see 3, 2, 6 is the n vector, because this is just capital A, B, C. This is general form, and the right side is just D. PS dot n, so which is 1, 1, 2 dot 3, 2, 6, which is 3 plus 2 plus 12, so should be 17. Okay, and for the distance, what do we need? Length of the n vector, so should be length of n, 9 plus 4 plus 36, so should be root of 49, should be 7, right? So the distance is ps dot n divided by the length of n, which is 17 over 7. That's all. So here you can try this exercise problem. Find distance from the origin to the plane. 3x plus 2y plus 6z equals 6. Here I can give you the solution. Let's take a look. First, I need to pick a point in the plane. So I'm going to pick the point, for example, if I make my xy 0, same plane. So just different point, right? This is my P point. And my PS 0, 0, 91. Okay, and my n vector 3, 2, 6. PS dot n, which is -6. Don't worry, it's negative because it's going to be absolute value or just absolute value of this one. And the distance is going to be an n-length vector, same as before, which is 7. So distance equals just the absolute value of that one, so which is 6 over 7. Okay. The last topic is going to be the angle between two planes. So it's like number 6, angle between planes. Okay, actually the angle between two planes is decided by the angle between those two normal vectors. So for example, here we have two planes. Okay, and here we have the normal vector. We say n1, n2. So this is like, for example, this is n1, and this is n2. The angle between those two planes is just same as the angle between n1 and n2. Okay, so we are going to do, you can see n1 dot n2 equals what? n1 length, n2 length, cosine theta, right? So how to find the theta? Theta is just given by cosine inverse of n1 dot n2 over length of n1 times the length of n2. So this is the formula for the angle between two planes. Let's take a look at our last example in this section. Okay, example 9. Find the angle between two planes are given by this. Actually, we just need the capital ABC, n1, n2. So no matter what is capital D, 2z equals 5. Okay, so firstly, we find the n1. n1, which is the normal vector for the first plane, 3, -6, and -2. And the n2, which is the vector, capital ABC, so just 2, 1, -2. And next, we just do the dot product and we find the length of n1 and n2, right? So maybe we can find the n1 length, which is actually 49, which is 7, and n2 length, which is root of 4 plus 1 plus 4, which is root of 9, and is 3. And the n1 dot n2 dot product, 2 times 3, 6, minus 6, plus 4, which is 4. Okay, so we just plug into the formula. Right now, our theta equals cosine inverse n1 dot n2 divided by the length of n1, length of n2, plug in. n1 dot n2, which is 4, n1 length 3 and 7, so it should be cosine inverse 4 over 21. You can leave the answer like this. You don't have to find the degree. If you have a calculator in the homework, you can try. And also it costs 79 degrees. Okay, so this is pretty easy, just a formula. So the most important part in this section, the first thing we need to know is the line equation, which is x equals x naught plus tv1. We need to know how to find a line equation for a given point and the direction. Okay, and plane equation, which is capital A. In calculus 4, you are going to use them a lot. For the line equation, you will find the tangent line in space. And for the plane equation, you are going to find the tangent plane for a surface. For example, you have sphere. How to find the tangent plane? Okay, so first step, you just find the derivative. You find the normal vector and find the point, something like that. The most important parts are those two, but we also learn some other things like distance from a point to a line and the distance from point to a plane, right? And the angle between on planes. And we also learned intersection line, okay, of planes. And what else? Intersection. This is the point, right? The point of line and plane. Those stuff, right? And I can give you the formula. So distance from the point, I think is cross product. So we did PS cross the v vector, and we take the length and divide by this one. And if you don't remember, you can always draw the graph. So as P and the distance, here's theta. So PS less times sine theta, right? Distance from a point to a plane, which is PS dot product, the n vector, and divide by length of n. Angle, cosine inverse, n1, n2 dot, divide by n length, n2 length. Intersection of line and plane, line of planes. So we do n1 cross n2, right? And intersection of line and plane. So just plug the line into plane, solve for t, and then plug t back into the line equation. We can find the point. So that's all we learned in this section, and they are everything we need to know for chapter 12. Okay, this section is pretty important. It's the application of cross product, dot product, parametric equations. So definitely in the future, we're going to use them a lot. Okay, so we can stop here.